So let's start with the isotopes. As we discussed about element compound mixture in the class, and we have already done about the atomic structure as well. So now we are going to talk about isotopes. Okay, so basically it is different atoms of the same element. For example, if you take hydrogen, it's an element. But if you take different forms of the hydrogen, that is going to be different isotopes of the hydrogen. Okay, what does mean by different forms of the hydrogen? It means we just said that hydrogen has one atomic number. If you go to the periodic table, you can see the hydrogen at the top having the atomic number 1. Okay. So atomic number 1 means it has one proton, it has one electron when it is neutral, right? So hydrogen has one proton and one electron when it is neutral. What about number of neutrons? We never said that the neutrons are also going to be equal because neutrons have no charge, so they are going to be different in different isotopes. If we consider 3 different forms of the hydrogen, we have like this. First hydrogen is H11. Second is hydrogen is H12. Third form of the hydrogen is H13. What does mean by this? If you remember this one number at the bottom, what it is representing here? One number. The small number is representing
The number of atoms.
atomic number or the number of protons, right? This number is the number of proton in all. This one number here is number of proton. Right. What about the bigger number? It is representing
atomic mass. Relative atomic mass.
Atomic mass. So it is representing number of protons and electrons together. So this one here is proton and neutrons together. Nucleus, nucleon number. So this one number is proton and neutron. This 2 number is proton plus neutrons together. This 3 number is proton plus neutrons together again. This number is different. Proton number is same. It means all have 1 proton. It means they have different number of neutron here. Getting the point? They have different number of neutrons here. So if we just try to subtract these two numbers, as we said that the mass number minus the atomic number is giving us the number of neutrons. You agree with this point? Mass number minus the atomic number is giving us the number of neutrons. So here you can subtract 1 minus 1 is giving you 0 neutrons. So in this first form of hydrogen, we have one proton, which is same like one electron, but the neutron is 0 here. Okay. Then for the second type of the hydrogen, if you subtract these two numbers, 2 minus 1 is giving you 1 neutron. So this hydrogen has 1 neutron, 1 proton and 1 electron. Okay. Third one, if you move to the third one, 3 minus 2 is giving you the number 2. So this hydrogen over here has 2 neutrons. Proton electron is 1. So what is different here? The number of neutron, right? The number of neutrons are different in 3 different forms of hydrogen. Yes, Wafia.
Miss, I have a question. The other day we saw that some elements have their atomic mass written in decimal notation.
That's a very good question.
So how come that the neutrons could be like in a decimal?
Right. That's a very good question, and that is the topic of today's class as well. Why some of the atomic masses are in decimals? Okay, so we'll talk about them. Okay, so then your question will be clear today. So over here, we have different number of neutrons. So it means all these 3 different forms of the hydrogen have same number of proton, same number of electron, but different number of neutron here, right? So these kind of the structures or these kind of the atoms of same element hydrogen is known as isotopes. Okay, so how we can define isotope? We can say it is different atoms of same element which contains same number of protons but different number of neutrons. Neutron number is different only. Okay, so many elements have the isotope, some elements have no isotope. So some has 2 isotopes, some has 3 isotopes, more than 7, 9, 12. Number of isotopes is different for every element in the periodic table. Hydrogen has 3 isotopes that you will remember. Okay. How we are going to write hydrogen in exam? Let's say you are writing, I'm using hydrogen for any experiment. Which hydrogen?
Miss,
The first
Miss Aisha,
hydrogen. Yes,
Miss
yes,
Aisha,
yes.
what is the isotope? I just joined from 3 minutes, and what is isotope?
Okay, we are talking about isotope basically. Isotope is different atoms of same element. Like we just said, it is different atoms hydrogen of same element hydrogen having same number of protons, same number of electrons, but different number of neutrons. Okay, so neutron number is here is 0 because we are subtracting these two numbers to get the neutron. Neutron number here is different, it's 1. Neutron number here is 2, it's different. Okay, so neutron number is changing because of which the mass number is also changing for all these 3 hydrogens. But still it is same element
So
hydrogen. Hydrogen could have 3 different
hydrogen could
forms,
have different masses.
different masses. Very good. Mass number is different because of different neutron number. So these 3 forms of hydrogen are known as isotopes of the hydrogen. Okay.
Miss, this is
So
only
how
in
we are going
hydrogen or
to all the elements in the periodic table have isotopes. Some don't have isotopes, but maximum have isotopes. Some has 2 isotopes, some has 3 isotopes, 7 isotopes, 9 isotopes. Okay, all will have different number of neutrons only. So hydrogen is one of the simplest example that we are talking right now. Okay, so now how we are going to write its name? We will not say all these 3 are hydrogen now because they are different from each other. So we will say this first one is hydrogen 1. What is this 1 number? 1 number is basically the mass number
So
here.
this one is not -1, not -1.
Not negative 1, hydrogen dash 1. It's not negative. Okay,
Oh,
it's
okay.
hyphen, hydrogen hyphen 1. So second hydrogen will be known as hydrogen dash 2. Again, this 2 number is the big number, mass number here. Third isotope of the hydrogen will be hydrogen dash 3. Here, this 3 number is the number of proton neutron together, the mass number. Okay, so like this, we can write their names here. Okay, yes, Wafia.
So, Miss, if an atom turns into an isotope, it's different from like normal atoms or something.
No,
I'm
no, no, no. It's
confused.
not turning into isotope. In air, if we have hydrogen gas, all these 3 isotopes are present in air. Okay. If we are using any element, we are not using the pure form of the element. We are using an element containing these 3 different isotopes. For example, for hydrogen, we have 3 isotopes. For carbon, we have 3 isotopes. Okay. So every element, if we just take it from the air, let's say any gas, it has all the isotopes mixed in the air. Okay.
And Miss, so
Hmm.
why is there different masses? Why there's different masses, even though it's the same atom? I mean the
Same
same
element.
elements. Same
So
elements,
same
yeah.
element can have basically different neutrons at the center. And it is stable in all these 3 forms. Some hydrogen
What is the
atoms
reason?
have 0 neutrons, some has 1 neutron, some has 2 neutrons. So these are the 3 stable forms of the hydrogen which are present. All 3 are present in air. Okay, but now, yes, yes. Yes, sure.
Miss, hydrogen number 2 shouldn't be the original form of hydrogen. Like we don't have to write number 2, or we wrote number 2 for differentiation.
No, we have to write the number 2. It's not the original form. Okay. From these 3 hydrogens, none is original. All 3 are present. All 3 are equally important. Okay, now your question is original. If you go to the periodic table, this one, you can see hydrogen at the top having the proton number 1, right? And the mass number is 1.01. It's not 1, it's not 2, it's not 3. It's different from all 3 isotopes. This is basically, we are taking this number as an average of 3 isotopes. Okay. how we calculate the average. It's not like first isotope of the hydrogen has 1 mass number, second has the 2 mass number, third has the 3 mass number, add them together, take the average. No, not this method of the average. Taking the average of isotope has a different method. And that average we are writing on the periodic table. That is the reason, Wafia's answer, that is the reason all these masses are basically in decimals. Because these masses are average of isotope masses. This point is clear? If still there is any question, you can ask.
Yeah.
Miss,
No,
can
Miss,
you
it's
explain
I
this
don't
answer?
What do you mean by average?
I mean, see, this hydrogen has the mass number 1. This has 2, this has 3. Now there is a confusion. Which one we should write on the periodic table? All 3 are equally important. So we have to take the average of their masses, the mass numbers, and then one average we have to write in the periodic table. And that is definitely going to be in decimal. Okay, but it's not the simple average. Taking the average of the isotope is having a method, a formula that we are using today. Okay, so that formula we have to use to find the average, and then that average is written in the periodic table. Yes, Wafia.
So, Miss, you can't have a pure form of a hydrogen atom in, let's say in air. You can't have like.
No, we have all 3 forms in the air. Okay, all 3 are present, but when we are using them in the questions, in the any type of the numericals, we are going to use the average of the mass of these 3. All 3 are present. Okay, same way, just like the hydrogen, we have isotopes of all the elements. Maximum of the elements of the periodic table are showing the isotopes. So we have carbon, let's say carbon has also 3 different isotopes. Let me show you over here. So carbon has one isotope, carbon 6, 12, second isotope carbon 6, 13, and the third isotope is carbon 6, 14. Now, quickly tell me what does mean by this 6 number here? Yes, Samreen. Any question?
Miss, I was asking that
Number of
why do we need the average? Like,
Why we
for
need the
example,
average?
if because in the air is present, all 3 of the hydrogen forms are present. So why do we need the average?
Because in the periodic table, we can write only 1. Okay, in the periodic table, we cannot write 3 isotopes of hydrogen, 3 isotopes of the carbon, 9 isotope of any other element. Then the periodic table is going to be a big periodic table. Okay, in the periodic table, we have to write the hydrogen 1 time only, where we have to write the average of all the isotopes of hydrogen. Okay. So, okay, coming back to the carbon, it has 3 different isotopes, just like the hydrogen. So this 6 number is, just tell me. Anyone can tell.
Miss, it's the number of electrons and protons.
Right. So we can
proton.
the number of protons
Number
are 6. Number of electrons are also 6. How many neutrons are there in the first isotope?
no, not this.
Subtract these 2
16,
numbers. Take the difference.
6.
12 minus 6. 6
6.
neutrons as well. Take the carbon 613 now. How many protons?
7.
6.
Oh wait, protons 6.
Electrons?
Electron
6.
Also 6. Neutrons?
7.
So 13 minus 6, 7 neutrons now. So neutron number is different here. Take the third isotope of the carbon. Protons again.
6.
Electrons
6.
and neutrons
8.
8. So now check out, they have different number of neutrons. Okay.
This
6, then 7, and then 8. So neutron number is different because of the difference in the neutron. They have the mass number different as well. Okay, because of this difference. Now, if you go to the periodic table and check out the mass number of carbon, let me show you the
Miss, I
periodic
have-
table
Miss,
here.
I have a question.
Just one
Miss,
second.
I have a
Here
question.
you can see the carbon mass is also in decimal, 12.01, not 12. Because this 12.01 is the average of masses of 3 isotopes of the carbon. Yes, Jude.
Yes, miss, my question is why only the neutrons can change the number, why not the protons or the electrons?
Basically, the protons and electrons have to balance the charge. Proton electron can also be changed. We can change the electron, we can remove the electron, gain the electron, it will make the ions. Okay, we can even change the number of proton. If we change the number of proton, it will change the identity of the element. For example, carbon has 6 protons. Boron has 5 proton. If you remove 1 proton from the carbon, carbon will change to boron. Identity will change. Getting the point? Proton is basically identity of any element, just like your identity is your fingerprint. If I change your fingerprint, your identity will change. Okay? Same like the protons have these protons are basically the element's fingerprints. We cannot change the protons, but if we try to change them, element will change to another form. Carbon will become boron if I remove one of the proton. And if I add one of the proton, it will become nitrogen in that case. If
Miss,
we
I have a
remove,
question.
yes, Luna.
Miss, do all the elements have fixed isotope?
No, no, no,
Isotope?
no, no. No, no, all the isotopes are not, all the elements does not have fixed isotopes. Some has 2 isotope, 3, 5, 7, 9, 8, 12, like this, different
Yeah,
number.
yeah,
Okay.
I know. So, like, for example, hydrogen has 3, for example, and then we said carbon has
Yes, yes,
3.
this number is fixed. Yes. Hydrogen has just 3.
This
Carbon has
fixed.
just 3. This number is fixed.
Yeah, that's what I'm talking about. Okay, thank you, Miss.
Yeah. So they have a fixed isotope, but not same. All elements have different isotopes, but their own isotopes are fixed.
Miss?
Okay, that number is not changing. Yes, Arish.
Miss,
When we were studying about the relative atomic masses, you said that carbon is the only one in the periodic table that does not have a decimal. Like,
Right.
but then
That is
here,
not having the decimal, and
thinking,
that is this carbon only. Carbon 12 isotope only. Okay. It's not these two isotopes. When we are comparing all the elements with the carbon, we are comparing with carbon 12 isotope only. Not with carbon 13, not with carbon 14 isotope. Okay. This mass number
Miss?
12, 13, 14 that you can see, this is the number of proton and neutron. The thing that I told you, it's the mass, the weight of element. Okay. The weight of element
Miss?
12 is not in decimal, but this is the mass number, which is proton neutron number together. Yes, Wafia.
Miss, I have 2 questions.
Hmm.
The first one is you said that the number of protons can't be changed in an element. Is that why?
Yes.
Is that the reason why elements, are unchangeable, so they can't be changing to like other elements? They can't be further broken down. That's the reason?
No, that's not the reason. Element cannot be further broken down means we cannot break one atom into further smaller pieces. That is a different thing. We can remove or add the proton to change the identity of the element, which is basically a very hard case. You can say a lot of energy or experiments are needed if we want to change the identity of the element. So in simple words, we can say proton is unchangeable. Proton is the identity of the element, so we are not going to change the proton, especially in your IGCSE syllabus. We are not going to change the identity of the element by gaining or removing the protons. We are talking only about the difference in neutron, and we are going to talk about the electron remove and gain, not about the proton. We will make the proton as a fixed number, unchangeable. Okay?
Miss? Okay, and
Yes,
Miss, I have another question.
Yes, Wafia, second question.
Miss, in the periodic table in our book, we don't have like many of the atomic masses are whole numbers except for chlorine.
Yeah.
It's different from the periodic table you showed us.
No problem. Whatever periodic table you have, you're going to use that periodic table. Okay. So
Okay, so
here I
why
am
is
using
that?
this periodic table. This is not your Cambridge periodic table. Okay. Because in the Cambridge, they're not giving you these decimal. They are just giving you the whole number for easy
Whole
calculation.
numbers.
Yeah, that
Yeah,
is for
but
easy
Miss,
calculation.
yeah, but Miss, even in the Cambridge periodic table, there's only chlorine that has It's atomic mass written in decimal notation.
Yeah, why it's only chlorine? That is also having a reason. See, if you check out the atomic masses of all other, if you just make them whole number, 10.8 is basically 11, right? 12.01 is basically 12. 30.9 is basically 31. In case of the chlorine, 35.45. We cannot say 35, we cannot say 36. If we make it even round off, it will be 35.5.
Yeah.
Okay, so that is the reason only chlorine is 35.5 in decimal in some periodic tables. All other are whole numbers because they are rounding them off.
Okay, thank you.
So even if you are getting a periodic table with round numbers or they are not rounded off, same thing. Whatever periodic table will be given, you are using that periodic table. Okay.
Miss, one question. Miss, oxygen, if you went back to the periodic table,
Yes.
oxygen and fluorine, they have like whole numbers. Why did they choose carbon, even though it had decimal numbers and the others it had?
I told you again, you're mixing two things together. These numbers are proton and neutron number. The number I told you, whole number, is the weight of the element. Okay? The weight or number of proton neutron is a different number. Okay? So don't confuse them or don't mix them together. These numbers are the numbers of protons and neutrons, not the weight. And these are basically the average number. This is the 16.0 whole number of isotopes of oxygen, not for one oxygen. Okay? So this is a different thing. Okay, now if we want to write the name of the carbon, just like the hydrogen, like this, what should be the name of this first carbon?
Carbon 12.
Carbon 12, okay.
Miss,
You will
why
be writing
12 now?
carbon dash 12. The second one, why 12? Because the mass number is 12. Same way, the second one is going to be carbon dash 13.
Carbon 13.
The third one is going to be
Carbon 13.
carbon dash 14, like this. Okay, so
Miss?
like this we can write the names of the isotopes.
Miss
Yes.
Aisha? Oh, Mama wants to ask you a question, so you can ask.
Yes, Mama, sure.
Miss, how will we know that how many isotopes each element have?
Basically, this thing we can test only by different experiments. So no need to remember the isotopes, how many they are, except for carbon, hydrogen only. That is in your syllabus. Even when you're getting the exam question, they will tell you how many isotopes are there. No need to remember this number. Okay? And we cannot do this by simple calculation. We can do this by experiment only, how many isotopes are there. Okay? Okay, now talking about the properties. All these three isotopes of the carbon, if I check, they have the same number of electron, right? Even if I check the three isotopes of the hydrogen, they also have the same number of electron because they belong from the same element. So if two elements, two atoms or three atoms have the same number of electron in the outer shell, it means they have same chemical properties. Remember this line. Chemical properties only depend upon the number of outer electrons. So all the isotopes of one element have same chemical properties. Why? Because they have the same number of electrons in the outer shell.
And also the same number of protons.
Also the same number of proton, but proton is not telling the chemical properties.
Okay.
Chemical properties only depends upon electron number in the outer shell. If atoms have same number of electron, it means they have same chemical properties. What is chemical property means? How they react. Are they reacting with the acid or no? Are they reacting with the metal or no? Are they reacting at room temperature or by providing heat? So their reaction basically is their chemical property. So that chemical property of all the isotopes of one element is going to be same. And the reason is because they have same number of electrons in the outer shell. Okay, now because they have different number of neutron, how the neutron is going to affect them? Different number of neutron is giving them the difference in physical property. Physical property means, is it heavy or light? Is it having more density or less density? Is it going to be having more boiling point, melting point, or less boiling point, melting point? These are the physical properties which depend upon the size. Less neutron means definitely it is, you can say, less in weight. More neutrons means definitely it is going to be little heavy. So neutron number changes in isotopes. So it means 3 isotopes of carbon or maybe 3 isotopes of the hydrogen are going to have different physical properties. Like they will have different density, different boiling and melting points. Okay. Then isotope appearance, how they look like. Isotopes look like alike. They're same in their looks because they are still the same element. Carbon, all 3 isotopes will have a similar color, similar structure, similar shape because they are again still the carbon. Only physical properties are changing. Chemical properties, their appearance, all these things will remain same. Okay. Now we can write them with full name, hydrogen 1, 2, 3, or maybe we can write the short form, symbol form. We can also write them H-1 for hydrogen 1, H-2 for hydrogen 2, H-3 for hydrogen 3. Okay, so like this, we can also write their short form for all the isotopes.
This like the what is it called, simple form. You know, in the periodic table they have symbols and do not write their full form. That's
Yeah,
what you
simple
meant?
form. Yeah. So we can have their simple form as well. Hydrogen 1, hydrogen 2, hydrogen 3. With the symbols or maybe with the name. Same for the carbon C12, C13, C14. We can write as well. Okay. So, okay, let's move forward. These are all about the properties of the isotopes. Now we have the next topic. Yes, Samreen, your question?
But would it be H2 because hydrogen? Like H2 because like this is a symbol, right? Would it
What
be
about?
H2 instead of H?
No, no, not H2. H2 is diatomic, means 2 atoms together. Okay. If you are writing H2, it means you are just making a bond between 2 hydrogens and making it H2. That is different.
Oh,
Yes, Wafia.
okay.
Miss, her questions made me confused. I'm
Okay, you can ask
lost.
whatever
What?
question you have.
Miss, no, the question, I think there was Samreen. I think the question she asked, it got me confused.
She said maybe she was trying to ask that can we write H2 instead of this?
Oh, that H2.
So this
Okay.
H2 is basically H2 gas when 2 atoms are together. That is a different thing. This is isotope
Yeah.
representation H-2. Okay, so these two are different things.
Yeah.
Okay.
Okay. Yeah, I
Move
got
forward,
confused
Shweta.
between.
Okay. Calculating the relative atomic masses. So this is basically the average of masses that I told you. We have a formula to find the average of different isotope masses. Okay. So formula is basically like this. First, I will tell you the formula, then I will explain you what does mean by these terms. Formula is, let's say, any element has 2 isotopes, A and B isotope. Okay. So percentage of isotope A multiply by the mass of isotope A plus percentage of isotope B multiply by the mass of isotope B divided by 100. And if we have 3 isotopes, we are going to continue percentage of isotope C multiply by the mass of isotope C. Okay, what does mean by percentage? So remember, if we are talking about 3 isotopes of the carbon, all these 3 isotopes total will be 100%. Okay, total will be 100%. But not all are 33, 33, 33 equal. Some isotopes will be in more percentage, some will be less percentage. Okay.
Like Miss, it might 29 point something or 20 something.
Yeah, maybe the one is 90%, the other is 9%, and the third is only 1%. Total will be 100%. Okay. So that is the reason, because their percentage is different and their mass is also different. So we need percentage and we need the mass to find the average. Yes, Varif.
Miss, how to find the percentage of each
Will
one?
be given to you. Percentage and masses will be given to you.
Okay,
Okay,
thank you,
no
miss.
need to remember this. Let's just quickly go to the question and then I will come back to this formula again so that there is no confusion. Let's say this is one question given. Okay, the table shows the information about the isotopes of rubidium. Rubidium is an element of the periodic table. Rubidium has two isotopes. Isotope number 1, which has mass number 85, and it has percentage abundance, means how much percentage? 72%. Okay. Second isotope of the rubidium has the mass 87 and the abundance is 28. So this kind of the table will be given to you. No need to remember their mass number, no need to remember the percentage. Now you have to just apply the formula and find what they're asking. They're asking find the relative atomic mass, means average, that we have to write in periodic table. Okay, so what I told you, you are going to take the percentage of first isotope, multiply by its mass, plus percentage of second isotope, multiply by its mass, divide with 100. So try to do this. See, percentage of first isotope is 72, multiply with 85 its mass, okay, plus percentage of second isotope is 28, multiply by 87. So same they did here, 72 multiply by 85 plus 28 multiplied by 87, total divided by 100. So here is the relative atomic mass 85.6, which is basically written in the periodic table.
Miss,
Okay,
it doesn't matter changed the order, right? Like
it doesn't
for
matter.
example,
Yeah. You can write 85 times 72, 75 times 82, maybe first isotope in the second place, second isotope in the first place. No, it doesn't matter. Okay. You have to just multiply mass with percentage of first, then add it with the second. Same way with the third, same way with the fourth. How many isotopes? Just do the same method. Yes, Wafia.
So, miss, when I checked my answer on the calculator, it gave me the answer in for two decimal places, 85.56. So we have to round it up.
No, see, it depends. In the exam, they will tell you how many decimals you have to write. See, give your answer in one decimal place. So if they're asking one, then we are going to round off and write the one decimal. Sometimes they will ask you to write the answer in 2 decimal place, in 3 decimal place. Whatever the question is asking, we are going to write according to the information given. Okay. So these are basically the average numbers which are written in the periodic table. So rubidium number 85.6 is written in periodic table. That is average of 2 isotopes. And average has a formula to find out the average. This formula. Okay. So now if we just go back to the information to check out, it is basically atoms are so small that we cannot compare their masses by just taking them on the simple weight scale. We cannot take them in kilograms or grams because atoms are very, very small. So we have to take their relative atomic masses in comparison with carbon-12. This is the same definition we did, that the relative atomic mass is equal to 1/12th of the mass of carbon-12 isotope, not carbon-13, 14 isotope. We are taking carbon-12 isotope and then we are comparing with that isotope and dividing them with 12 to get 1 unit. Okay, this thing we did already. Okay, for example, the hydrogen has relative atomic mass of 1, which means 12 atoms of the hydrogen would be equal to having the same mass like 1 atom of carbon. Because carbon has 12 mass, hydrogen has 1 mass. So 12 hydrogens are equal to 1 carbon. Okay. So relative atomic mass of each element is calculated by using its mass number and its percentage. Percentage is also known as abundance. Write this with you. In the exam, sometimes they will not tell you that the percentage is given. They will tell you abundance is given. Abundance means percentage. Okay, relative abundance means how much percentage of every isotope is there. Okay. So there is one question in one of the IGCSE exam as well that they asked you in the question for 1 mark, if you want to find relative atomic mass, what information you need? So you will just write the answer. We need mass number and we need the relative abundance or percentage.
We need the relative abundance, yes.
Right.
Miss,
So we need abundance and we need mass number to find relative atomic mass.